Hello, how's it going? We'll talk more about solving equations today. And we'll start with some definitions, and then we'll review linear coupled equations and nonlinear equations, and then talk about args and kwargs. Linear equations, those are when the variables have a power of 0 or 1. And nonlinear equations, of course, have powers greater than 1, or nonlinear functions such as a sine or exponential. Coupled equations, those that have multiple equations to be solved that have common variables. And of course, non-coupled is the opposite, where the variables are not common between the equations. Those definitions are important because you can use different methods to more efficiently solve depending on what kind of equation set you have. And so we talked about this last time, but a times b equals, or a times x equals b, kind of a right here where you have your linear algebra, and you can solve for what the x values are given a and b. And you use matrix, you invert the matrices. So here's an example, and I can run it with setting a equal to coefficients, and then b's are the answers, and then I have my array of variables. And then linalg solve will solve that once you've put that in as a multi-dimensional array for A, and you can use a list for the B values. And there are more linear algebra operations with Numpy at this link right here. It's the documentation link. And nonlinear equations, we typically use fsolve, and for instance here, there's two roots. It's like a parabola, and here we define our function, and we want to see where that function equals 0. That's the definition of a root, is where the y value equals 0, for instance. And we use our fsolve from the Sympy package, and we have to give it a guess value. So we specify our function, we call the function right here. It needs to be a function of one variable, and then here's our guess. You can use multiple variables, and we'll talk about that, but it has to be in a list or an array. And here it solves that for us, 2.23. And you can get an array of guesses like I just mentioned, but well, I think there's an example down here that we'll go through. So multiple equations and multiple unknowns. So this is a function equal to x, so we're trying to solve that. Or we can make it an array of functions and multiple variables. So x is a vector, and f is a vector of functions. So we have two functions here. Let's say h and g, y plus 2z, and sine y divided by z. And we can write that something like this right here, or like this. So we can solve them just as before, where we define our function. There's our function definition. We can pack it so it's a tuple, and then we can pull it apart like so. YZ is a variable name, and it's a tuple, so you'd feed it like right here, the guess values in a tuple. Or you can use a list, and it will pull them apart, so y and z, and then you can use those to calculate your function values. And then you're using fsolve for that function given your guess value, and your guess value is a tuple or a list. And then you print out yz0 and yz1, and it will, that's your solution there, 3 pi and negative 1/2. But we all know that sine has multiple times it crosses the x-axis, and so here you might expect multiple solutions depending on your guess value. So here's my guess value of 1 and 2, but I can do multiples. So here I do a different guess value of 102 versus 1 and 2, and I get, of course, a different answer for the root of the solution to that. And I can even do a bunch of different guesses and do a nested loop, and then solve for each of those, that system of equations for each of those guess values. And I'm appending it to a dictionary here. And then I'm plotting, and then I'm putting it in a data frame of the solutions right here. And there's 224 of them based on this. So there's 100 y guesses and 100 z guesses. So the number of unique solutions, so that's 10,000 times it did the fsolve, and it found unique solutions for 224. Because we dropped the duplicates, that's a slick way here. If you read it into pandas, you could also use a set. Anyway, here is the plot of the z solutions divided by pi and y divided by pi, and you can see they're related. And approximately z equals -1/2 y. Sympy will also solve things for you, and you can use it symbolically. So fsolve, we just put those two equations in. So you put it in as a list with the functions given here, and then here is your guess value. Well, actually not your guess value, but your variables that are changing. So, and then it will solve these. Y is -pi and z is pi divided by 2. You can see that's consistent with this. Sympy solver. And here's another system of equations that's nonlinear. And I've got this set up. I put that in as a function. Return my 3 values here. And put my function in right here. And it has one variable, and that variable is a tuple, and I can unpack the tuple and then use the unpacked variables inside my equations, and then it will solve it. And it does depend on the guess value, and I similarly loop through here and find all the solutions, and there was 20 for about 1,000 times, it looks like. I did that fsolve. And here is it reading in for the pandas, putting it in a data frame, and then dropping the duplicates. And there's a list of all the solutions that were found. Now switching quickly to args and tuple expansion. So you should be familiar with this as far as this star args. So you can feed into your function. Here I've defined it, and then I fed in a bunch of stuff that it necessarily isn't defined in the function call right here, the inputs. And it will pull all these apart, and you can see it pulls them apart there. And then for arg and args, it prints them all out. And I can even call like an a. For instance, right here, a is this value. And of course there would have to be an a fed in, like right here, there's a dictionary that's fed in that has an a as a key value, or a key, and then this is the value for that dictionary, and that prints right here. So this is a way to not necessarily specify all the arguments that you might use in a function, or you could pass multiple different ones. You're not sure which arguments the user could pass in there. So there's a couple examples here on how to use that args function here. Like you can just have it expand it from a tuple. So you feed it as one value, but if you put the star in front, it'll pull it all apart. And then you can use this function in a similar way. And here I've done an integration example. Quad is this quad function from Scipy integrate. Will integrate under a curve or a relationship. And here I'm using the args function to specify additional args given my function has default values. And I can check if args is none. But this is an example as far as using non-required arguments that you could change default values inside your code, for instance. And the last topic is kwargs. Kwargs, you're going to see this when you look up documentation in Python. You're going to say, what is going on here? What's this kwargs? What it is it just pulls apart a dictionary, or it makes it into a dictionary when you feed it. So if I feed function these values, I put it in there, it sticks it in as a dictionary. So now my kwargs is, you can cycle through the items in this kwargs. It's now a dictionary, so the double stars means whatever is passed into here, turn it into a dictionary. And here I refer to it as kwargs A. Notice I have to feed it an A to have this work, but you can pass any number of things that may or may not be used, and it just makes it easier sometimes to refer to it as a dictionary item, like a label and so forth. Anyway, hopefully that's helpful. Hey, God lives and loves us.